Homework from 7-4. Number 6, using a half-angle formula. So that means first we need to rewrite it as something divided by 2. That would be pi over 4 divided by 2. Then plug it into the formula, plus or minus the square root of 1 minus the cosine over 2. Deciding on the plus or minus, we'd go back to the original. That's in the first quadrant, so that means we're going to be positive. The cosine of pi over 4 is the cosine of 45 degrees, which is square root of 2 over 2. We need a common denominator on the top. Get rid of the fraction in a fraction by multiplying by the reciprocal to get your final answer. Number 7, using a half-angle formula. So we need to rewrite it as something divided by 2. That's 330 divided by 2. So we'll plug it into the formula. 330 degrees is in the fourth quadrant. It has a reference angle of 30 degrees. So I'll draw a 30, 60, 90 right triangle. Before I get too much further, I should decide on the positive or negative. 165 is in the second quadrant. In the second quadrant, tangent is negative. So my answer is going to be negative. Cosine of 330. Well, the cosine of 30 is square root of 3 over 2. 330 in that quadrant, cosine is positive, so I don't need to change the sign. It was a minus here. It's going to be a minus here also. Same thing on the bottom of the fraction. Like we said in class, there are multiple ways to simplify this. I'm going to choose to just multiply by the conjugate. When I do that, I get 1 minus 2 copies of the square root of 3 over 2 plus 3/4. And on the bottom, I get 1 minus 3/4. Combining like terms, that is 7/4 minus square root of 3 over 1/4. Multiply by 4 to get your final answer. Use the given information to find the sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. I'm going to start by drawing a picture. Here's my theta. It has a sine of 2 over 5. Use the Pythagorean theorem to find that missing side length. And now just use the formulas to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Sine of 2 theta is 2 times the sine times the cosine. Looking at my triangle, the sine is 2/5. The cosine is square root of 21 over 5. Always stop to check positives and negatives. In this case, we're in the first quadrant, so everything is positive. We don't have to worry about it. Multiply your fractions straight across to get 4 square root 21 over 25. Same process for the cosine of 2 theta. The formula for cosine of 2 theta is cosine squared minus sine squared. Using the triangle, cosine is square root of 21 over 5, so we're going to square that. Sine is 2 over 5, we'll square that. Squaring the top and the bottom of the fraction, we get 21 over 25 minus 4 over 25, which is 17 over 25. Last one is tangent of 2 theta. The formula for tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. So that's going to be 2 times opposite over adjacent over 1 minus that same number squared. On the top, that's 4 over the square root of 21. On the bottom, that's 1 minus 4 over 21. Get a common denominator. 4 over the square root of 21 over 21 minus 4 is 17 over 21. Flip and multiply. And then I'm going to rationalize in this same step. So I'm going to also multiply by square root of 21 over square root of 21. The reason I'm doing that all at once is this is 21 and that's 21, so they're going to cancel. In lowest terms, I'm going to have 4 times the square root of 21 over 17. Number 9 is the same sort of problem. The only thing that's different this time is we are going to have to be careful with positives and negatives because we're not in the first quadrant anymore. I'm going to start this one out the same way by drawing the right triangle. It has a tangent and opposite over adjacent of 4 over 3. Use the Pythagorean theorem to find the hypotenuse. And fortunately, the hypotenuse ends up being a nice whole number. It's 5. We're supposed to figure out the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. Sine of 2 theta is 2 times the sine times the cosine. So that's going to be 2 times the sine opposite over hypotenuse is 4/5. The cosine adjacent over hypotenuse is 3/5. But this is the part where we always need to check the positives and negatives. Pi to 3 pi over 3 is the third quadrant. In the third quadrant, sine is negative and cosine is negative. So multiplying straight across, 2 times -4 times -3 is -24. Positive 24, pardon me. 1 times 5 is 25. So our answer is 24 over 25. Cosine 2 theta. Formula for cosine 2 theta is cosine squared minus sine squared. Using the triangle, cosine is 3/5, sine is 4/5. Now remember, you're in the third quadrant, so everything's negative. We need a negative sign there and a negative sign there. Fortunately, when you square a negative number, it ends up being positive again anyway. So we have 9/25 minus 16/25, which is negative 7/25. Last one is the tangent of 2 theta. Double angle formula for tangent is 2 times the tangent over 1 minus tangent squared. We have right in the problem that the tangent was 4/3, so 2 times 4/3 over 1 minus 4/3 squared. That is 8/3 over 1 minus 16/9. Get a common denominator. 8/3 over negative 7/3. Negative 7/9. Multiply by the reciprocal. I'm going to reduce before I multiply. I'm going to make this into a 3, that into a 1. When I multiply straight across, I get negative 24 over 7. 10, 11, and 12 are all verifying ones. On number 10, I'm going to work on the right-hand side and change everything into sines and cosines. Then I'm going to get a common denominator by multiplying this by sine over sine and multiplying this by cosine over cosine. That'll give me 2 over cosine squared minus sine squared over cosine times sine. Now I'm going to flip and multiply to get rid of the fraction within a fraction. So that means I'm going to be multiplying by cosine sine over cosine squared minus sine squared. So on the top, I'd get 2 times cosine times sine. On the bottom, I have cosine squared minus sine squared. Those two should look familiar, like formulas you have memorized. 2 times cosine times sine is the double angle formula for sine. Cosine squared minus sine squared is the double angle formula for cosine. And sine over cosine equals tangent, and that's the other side. Number 11 is a verify problem also. Verify that 1 plus 1/2 sine 2a equals secant plus sine over secant. I'm going to work on the right side again and change everything into sines and cosines. There are multiple correct ways to go from here. What I'm going to choose to do is get rid of the fraction within a fraction, and I'm going to multiply the top and the bottom by cosine. Now when I multiply the top by cosine, I need to distribute it and multiply it to both parts. That's why we usually make the top all one fraction before we flip and multiply. In this case, it's going to work out kind of nicely because cosine times 1 over cosine is just 1. And then we have plus sine A cosine A. Looking at where I'm going, I'm on the right track because I have this 1. And now I just need to figure out this 1/2 sine of 2a. So I'm going to go back and think in my head, what's the formula for the sine of 2a? The formula for sine of 2a is 2 times sine A cosine A. And then there's this 1/2 out front. Look at that, the 1/2 and the 2 would cancel, and I'd just be left with sine A cosine A. So the way I'm going to get here is I'm going to change this to 1 plus 1/2 times 2 times the sine A cosine A. Notice I didn't change its value, I just multiplied by 1. I multiplied by this, and that's 1. Now I can kind of regroup it and say this right here is the double angle formula for sine, and I'm all set. Number 12 is the last one, another verify problem. This time we're going to use a half angle formula to figure it out. The half angle formula for sine is the square root of 1 minus cosine over 2. We're multiplying that by the half angle formula for cosine is the square root of 1 plus cosine x over 2. Now I'm going to multiply them together. We're allowed to multiply square roots. When we multiply them together, the pluses and minuses are going to cancel out. On the top, I'm multiplying together conjugates. So the outsides and insides are going to go away, and I'll just have 1 minus the cosine squared of x. On the bottom, I get 4. This is one of the big three. Sine squared plus cosine squared equals 1. So 1 minus cosine squared would just equal sine squared. When you're taking the square root of the fraction, you take the square root of the top. The square root of sine squared is just sine. And take the square root of the bottom. Square root of 4 is 2. And that's the other side.